Hey everybody, let's try this space truss problem. So let's see, we're asked to find the axial forces in member AB, AC, AD. So basically it's the method of joints, starting at joint A, and then you could continue, you go to joint B, C, D, and you can solve for the axial forces everywhere. This particular problem is only asking for these three. So let's start with joint A. Right, so there are axial forces, let's call it AB, AD, AC, and then a load here, which is given right here. Okay, so basically we can write three equations. And solve for our three unknown axial forces. That's it. Okay, but before we do that, why don't I break down each of these vectors into components? Okay, let's start with the easiest one, vector F. Right, so it's 0I plus 40J plus 0K, right, kilonewtons. How about vector TAB? Okay, it's some unknown magnitude of this, unknown. But the direction is the unit vector from A to B. Right, so the unit vector from A to B, which we can get. Right, because what is the vector from A to B? 0 minus 1.1. 1 minus 1.1 I, 0 minus negative 0.4, so plus 0.4 J, and then 0 minus 0 K. Okay, and then for the unit vector, divide by its own magnitude. All right, so then here we go. So that's vector TAB split up into components, and then we do the same for AC, we do the same for AD. Okay, so vector TAC has some unknown magnitude, but the direction is the unit vector from A to C, which we can get. Right, so from A to C, so where's point C? That's 0I, 0 J, 0.6 K. Okay, so from A to C, 0 minus 1.1 I, 0 minus negative 0.4 J, 0.6 minus 0 K. Right, and then for the unit vector, just divide by its own magnitude. Okay, and then for AD, like same story, unknown magnitude, but the unit vector from A to D we could get. All right, so from A to D, where's D? Over here. Okay, so D is at 0I, 0J, negative 0.4 K. Okay, so from A to D, 0 minus 1.1 I, 0 minus negative 0.4 J, negative 0.4 minus 0 K, and divide by its own magnitude. Okay, so we have all four vectors split up into components. So all we need to do is some forces in the x direction. So 0 of this, negative 0.1 over that thing, this thing. Okay, let's see, just so it's less writing. So that's 0.16 and 0.01, so that's 0.17. There, okay. TAB, and then the x component of this, so that would be minus 1.1 over square root of this thing. Let's see. So that's like 1.21 plus 0.16 plus 0.36. So that's like 1.23. Let's see, 6, 12, 13, 1, 4, 7. Okay, like that. TAC. Okay, and then the x component of this, so that's negative 1.1 over, let's see, oh, let's actually, this should have been a 0.4. Okay, so that's so 1.21, 0.16, 0.16, so 12, so that's 3, 5, so 1.53 TAD. Okay, and then you do the same, right, the y component. So the y component of that, 40. What's the units? Kilonewtons. Right, and then the y component of this. Let me space out a little bit more. Okay, so the y component of f, 40. The y component of TAB plus 0.4 over square root of 0.17 TAB. Okay, the y component of this is right here, plus right here, 0.4 over square root of 1.73 TAC, and then the y component of this, which is right here, square root of 0.4 over square root of 1.53 TAD. Okay, and then finally in the z direction, the z component of this, which is 0, the z component of this, which is 0, z component of this, which is right here, 0.6 over square root of 1.73 TAC, and then the z component of this, which is right here, negative 0.4 over square root of 1.53 TAD. Okay, now we have 3 equations, 3 unknowns. The unknowns are here. Okay, so if I take a look at it, this only has 2 unknowns, so that's nice. So I would like to combine these 2 to get rid of TAB. So for example, you could solve, let me label these. You could solve equation 1 for TAB. So for example, okay, so this is that same equation. So I could move this to the other side of the equation. right there. And then just multiply by the reciprocal here. So TAB is 0.17 over 0.1 times 1.1 over TAC minus 0.17 over 0.1 times 1.1 over. Okay. So I solved equation 1 for TAB. Then I can take this and plug it in right here. And then what would that accomplish? Then I would have, so let me just do it. Right, so right, all of this goes right there. Okay, so this, let me make more space. Okay. All right, this goes right there. But what does that accomplish? Now take a look. This is only two unknowns, TAC, TAD. This one is also two unknowns, TAC, TAD. So these two equations, right? Two equations, two unknowns. You know how to solve two equations, two unknowns, right? You could, for example, take this one right here, equation 3, solve for, let's say, TAC. TAC equals root 1.73, let me write nicer, over 0.6 times 0.4 over root 1.53 TAD, right? So take this and plug it in right here and right here. Then you would have one equation for one unknown, TAD. So then solve for TAD. So then you'd have that number, plug it in right here. Now you have TAC. So now you have both TAD and TAC. Take those values and plug it in right here. TAD, TAC, and then you got TAB. Done. 3 equations, 3 unknowns. Okay? So keep on practicing these skills. I'll see you on the next video.